Hello everyone, it's a pleasure meeting you all in my mathematics class. Today let me do the problem in Fourier series. The problem is if f of x is equal to sin x defined in the interval 0 to pi and takes the value 0 in the interval pi to 2 pi, we have to get the Fourier series of this function f of x. And see, the periodicity is 2 pi because it is defined from 0 to 2 pi, and therefore the periodicity is 2 pi. And also we have to evaluate, after getting the series, we have to evaluate this particular result to find the value of this series 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 up to infinity. Now this is a Fourier series problem, and therefore let me write here. See, here you are given. See, we know that the Fourier series for any function is given by a0 by 2 plus sigma of 1 to infinity of an cos nx plus 1 to infinity of bn sin nx, and that this a0 is equal to, it is 1 by pi 0 to 2 pi, it is f of x dx, and an is equal to 1 by pi 0 to 2 pi f of x cos nx dx, and bn is equal to 1 by pi 0 to 2 pi f of x into sin nx dx. These are all called the Euler coefficients or the Fourier coefficients. What we have to find the we have to evaluate these integrals, substitute in this one. Let me call this as my 1, substitute in 1, evaluate these integrals, substitute in 1, then you get the Fourier series. After getting the Fourier series, we will then find the value of this particular series. Now what is a0? See, a0, let me write here, a0 is equal to 1 by pi, it is 0 to pi f of x dx plus it is pi to 2 pi f of x dx. So this is because this function f of x is defined in the interval 0 to pi and pi to 2 pi, and therefore this will be equal to, so you see that this is 0 for the simple reason that f of x is equal to 0. So we are left out with 1 by pi, it is 0 to pi, f of x is nothing but your sin x into dx. But sin x, integration of sin x is minus cos x, and it runs from 0 to pi, 1 by pi. So this is 1 minus 1 by pi into cos x 0 to pi, that is minus 1 by pi cos pi minus cos 0. Cos pi is minus 1, minus 1 by pi minus 1 minus 1, that is equal to 2 by pi. So call this as your A. So you see that what is that I have done here is f of x, see, it is defined only in the interval 0 to pi, and in the other half pi to 2 pi, the value of the function f of x is 0, and therefore you see that this is 1 by pi 0 to pi sin x dx, but integral of sin x is minus cos x, so this is minus cos x. Apply the limits and you get this result, because cos pi is minus 1, cos 0 is 1, cos pi is minus 1, cos 2 pi is plus 1. So for even values, for even numbers, the value of the cos function is 1. For odd values, it is cos n pi is equal to minus 1 plus 1 minus 1 plus 1, depending on whether n is odd number or even number. So therefore we get this 2 pi. So let me call this as a, so that I will substitute in n. Now let us find what is our an. So therefore, and what is our an? An is 1 by pi. I will straight away write this as 0 to pi into sin x into cos nx dx. Why I write like this? Because you see that this function, it is 0 to 2 pi only, but pi to 0 to pi f of x is sin x. See, likewise, here it is 0, this value is 0, and here it is f of x, but f of x is sin x and into cos nx dx, because an is 1 by pi into so much. Therefore, you see that this function has been defined only in this particular integral. Though it is defined from 0 to 2 pi, its value from pi to 2 pi is 0. And it is sin x in the interval 0 to pi. Therefore, I write like this. Now, it is for you to integrate, know how to integrate these integrals of this type. What I do is, I multiply this by 2 and divide it by 2. 0 to 2 pi sin x cos nx dx. And you see that this, if I see it, this is 2 sin a cos b. We know that sin a cos b, see, sin of a plus b plus sin of a minus b. This is sin a cos b plus cos a sin b. Therefore, here it will go, so you will get only 2 sin a cos b. So, I am trying to identify this way and understand that you can integrate a function only when it is in the sum form. When it is in the product form, it has to be brought to the sum form. Some manipulations have to be done before doing the integration. We cannot straight away get. Here this is in the product form, so I am trying to bring it to the sum form. Now what is 2 sin x? This is on the form 2 sin a cos b. Say 2 sin a cos b is what? Sin of a plus b plus sin of a minus b. So this can be written as 1 by 2 pi, within brackets it is 0 to pi. Here it is, I will write this as sin of x plus nx plus sin of x minus nx. This has to be integrated. So we have to integrate. Now you see that I am able to bring it to the sum form. So now this integration is simple. The integration of this simple, integration of this is simple. Therefore, if it is product, bring it to the sum form. So I will write this as, I'll write this as 1 by 2 pi into, it is I1 plus I2. I1 plus I2. Now, I1, what is your I1 now? I1 is nothing but your 0 to pi sin of x plus nx dx. But this is sin theta. Integration of sin theta is minus cos theta. So this is cos of, this is on the form, you can write this as n plus 1 of x divided by n plus 1. So this is what you get. Now you see that this, this is from 0 to, the limit is from 0 to pi. And this can be written as, I will write this as cos of, it is x plus nx divided by n plus 1, 0 to pi. So this is nothing but minus cos of pi plus n pi divided by n plus 1 minus cos of 0 divided by n plus 1. So I write this as cos pi plus n pi. So this I will straight away write this as minus cos of, this is cos 180 plus theta. Cos 180 plus theta is cos theta, but 180 plus theta lies in the third quadrant. Therefore it is minus cos theta. Cos of 180 plus theta is minus cos theta. See, cos of 180 plus theta is equal to minus cos theta. Cos of 180 minus theta is also equal to minus cos theta. This will lie in the second quadrant. This will lie in the second quadrant, whereas this lies in the third quadrant. So is cos of 180 plus theta is minus cos theta. Cos of 180 minus theta is also equal to cos minus cos theta. So this is minus cos theta. So you see that I can write this as minus cos n pi divided by n plus 1 minus cos 0 is 1. So cos of n plus 1. So if you take this minus sign inside, this is nothing but cos of n pi divided by n plus 1 plus 1 by n plus 1. Take this minus sign inside. So this will be equal to cos n pi is minus 1 to the power of n divided by n plus 1 divided by n plus 1. So call this as your, I will call this as my, this is I1. This is your I1 result. So what is that we have got here after doing this? See, this is a very simple integration, and apply the limits, you will get the value. So minus 1 to the power of n divided by n plus 1 plus 1 by n plus 1. Now what is your I2 now? I2 is 0 to pi. See, I2, your I2 is here. I2 is, it is sine of, see, your I2, see, I2 is sine of x minus nx dx. So here again this is nothing but minus cos of x minus nx divided by 1 minus n, because this is 1 minus n of x. This is nothing but what? This is nothing but sine of 1 minus n of x. So this is sine of 1 minus n of x. So the integration of this is minus cos x minus nx divided by 1 minus n. So this is from, take this outside, so 0 to pi. Now you apply the limits here. So minus cos 180 minus n pi divided by 1 minus n minus, you put x is equal to 0 here, cos 0 is 1, so 1 minus n. So this is equal to, so you see that this is nothing but 180 minus theta. See, cos of 180 minus theta is also equal to minus cos theta. So this is minus cos n pi divided by 1 minus n minus 1 by n minus n. So this is nothing but, it is minus 1 to the power of n. See, minus, if you take it inside, it is n minus 1. And you take this minus sign outside, it will be plus 1 by n minus 1. So this is equal to minus 1 to the power of n divided by n minus 1 minus 1 by n minus 1. This is I1 and this is I2. So I got the values of I1 and I2. Now substituting in what? See, I will substitute in where, see here you have got here. See, let me call this as B. Let me call this as B. So substituting in B, we get A and C. This is your A N. Here you have got here, see, B is here, so AN is here. So this is equal to 1 by pi. We get AN is equal to 1 by 2 pi into what is your I1 minus 1 to the power of n divided by n plus 1 plus 1 by n plus 1 and plus, here you have to take this, so it is plus or minus means it is minus 1 to the power of n minus 1 minus 1 by n minus 1. So this is what you get here. So this is nothing but 1 by 2 pi into minus 1 to the power of n divided by n plus 1 minus 1 to the power of n divided by n minus 1 plus 1 by n plus 1 minus 1 by n minus 1. So this is what we get. Now this on simplification gives, see, A naught value has been found. A naught is equal to 2 by pi. A naught is equal to 2 by pi. Now let me rub off this. Now what is now AN? Therefore AN is equal to, if you take the LCM here, it is n square minus 1 by 2 pi. It is n minus 1 minus n minus 1, because this n plus 1 minus n minus 1 plus it is n minus 1 minus n plus 1 divided by n squared minus 1. And here you must know that n is not equal to 1. If you put n is equal to 1, this will become infinity, because some constant here be 0 is infinity, which we cannot admit. So you see that it cannot be infinity. So what we do is, this result is not applicable for what? N is equal to 1. For n is equal to 1, we will find it separately. Okay. Now, so this is equal to, so here you see that this is n minus 1 minus n plus n goes off, giving you 1 by 2 pi into minus 2 divided by n squared minus 1 minus 1 to the power of n plus, see, when you open this bracket, it is minus n and plus n goes off, minus 2. So it is again minus 2 divided by n squared minus 1. So you see that here, take this minus 2 outside, so it will become minus 1 by pi. It is minus 1 by pi into within brackets, it is minus 1 by pi into n squared minus 1. If we take these things outside, so it is nothing but it is minus 1 to the power of n plus 1. So this is the result that we get. That means an value has been obtained as this. But here this n is not equal to 1, because if you put n is equal to 1, this will become infinity, therefore, which is not admissible, and therefore an value is this for n not equal to 1. So it is for n not equal to 1. This is n is not equal to 1. Now, more and more than that, what happens is here, so I will write here. So what is your an now? So an, we have got the value of an. We have got an is equal to minus 1 by pi into n squared minus 1 into minus 1 to the power of n plus 1, n not equal to 1. But here again, see, when n is odd, say put n in, when n is odd, when n is an odd number, this will become minus 1. Minus 1 plus 1 will be equal to 0. So when n is odd, an is equal to 0. When n is even, an will be equal to minus 1 by pi into n square minus 1. See, when it is even, minus 1 to the power of even number is plus 1. So this will be equal to your 2, because this will be 1. 1 plus 1 is 2. I'll write it here. 1 plus 1. So you see that when you put n an even number, minus 1 to the power of n will be positive. So 1 plus 1 is 2. So what is that you will get here? It is equal to minus 2 by pi into n square minus 1. So this an has got value only when n is even. For n odd, it is 0. And moreover, this n is not equal to 1. So what is that we have got here? So an is equal to minus 2 by pi into n square minus 1. N is even. N is even. And an is equal to 0, n odd. So for the odd values of n, this an is 0, and therefore this. Now what is your a now? When n is equal to 1, what will happen here? When n is equal to 1, see, when n is equal to 1, a1 will be equal to 1 by pi into 0 to pi. It is sin x into cos nx dx. Sin x into sin x cos nx. If you put n is equal to 1, this will become cos x. Because n is equal to 1 means what? It is cos x. So this is nothing but 1 by 2 pi into 0 to pi sin 2x. Because it will be 2 sin x. I will put it as what? I will multiply this by 2 divided by 2. 2 sin x cos x is sin 2x into dx. That is equal to 1 by 2 pi into minus cos 2x divided by 2. See, it is divided by 2, 0 to pi. So this is nothing but 1 by 4 pi minus 1 by 4 pi into cos 2x. It is 0 to pi. See, cos 2 pi is, so this is nothing but minus 1 by 4 pi cos 2 pi minus cos 0, but that is equal to minus 1 by 4 pi into 1 minus 1, that is equal to 0. So you see that because cos 2 pi is plus 1 and cos 0 is 1, so the value of this is 0. So a1 is 0. So a1 is equal to 0. See, we are getting a1 is equal to 0. An value we have got for odd values it exists, for even values it exists, for odd values an becomes 0, and we have got the first result. Now let us try to see, this is over, this we have done, this we have done. Let me come to this one. What is our bn now? What is bn now? Bn, see, bn is equal to, see, bn in the similar way I can write this as 1 by pi into 0 to pi. It is sin x into sin nx dx. So this can be written as 1 by 2 pi. This is nothing but your 1 by 2 pi 0 to pi 2 sin x into sin nx dx. Now 2 sin a sin b is nothing but it is 0 to pi cos of 2 sin a sin b. See, what is 2 sin a sin b? See, 2 sin a sin b is equal to cos of a minus b plus cos of a plus b. Because cos a cos b is nothing but cos a cos b, here it is minus see that this is cos A minus B plus minus cos of A plus B. Cos A minus B is cos A cos B plus sin A sin B. And this is cos A cos B minus sin A sin B. Here you see that this will become 2 sin A sin B. So I am going to use this formula here. So this is nothing but cos of, it is x plus, see, x minus nx dx plus 1 by 2 pi 0 to pi cos of x plus nx dx. Now this is nothing but, I can straight away write this 2 by pi, it is minus integral of cos is sine, this is not minus, it is simply sine of x minus nx by 1 minus n plus sine of x plus nx divided by 1 plus n into 0 to pi. So this is 1 by pi into, if you substitute pi here, cos of, it is sine of pi minus n pi divided by 1 minus n. If you apply the second limit, it is minus, it is sine of 0 divided by 1 minus n plus sine of pi plus n pi divided by 1 plus n minus sine 0 divided by 1 plus n. And try to understand that n is not equal to 1. If you put n is not equal to 1, say this is applied, bn is equal to this and n is not equal to 1. Because if you put n is equal to 1, this will become naturally, again the same case, it will become infinity. So this. Now you see that this is nothing but 1 by 2 pi sine of 180 minus theta. Sine of 180 minus theta is in the second quadrant where sine is positive. So this is sine of n pi divided by 1 minus n minus sine 0 is 0 plus this is sine of 180 plus theta is in the third quadrant. So it is minus sine n pi divided by 1 plus n minus, again it is 0. But sine of n pi is equal to 0 for all values of n. Sine n pi is equal to 0 for all n. For whether it is positive integer or negative integer, whatever be the value, it is going to be any integer, positive or negative integer, it is going to be 0. So this will be 0 again and this will also be 0. So you see that this whole thing will become 0. So your bn is equal to 0 for n not equal to 1. So we have got this bn is equal to 0 now. So bn is equal to 0. Now what is your b1 now? Let me find out what is our b1. b1, what is b1? b1 is equal to 1 by pi 0 to pi sin x into sin nx, sin x. But n is equal to 1 means again sin x into dx for n is equal to 1. For n is equal to 1. So this is nothing but, again you multiply this 1 by 2 by 0 to pi. It is sin squared x, 2 sin squared x into dx. But you must know that cos 2x is equal to 1 minus sin squared x. This implies 2 sin squared x is equal to 1 minus cos 2x. So in this place we can write this as 1 by 2 pi, it in within brackets 0 to pi 1 minus cos 2x into dx. So this is equal to 1 by 2 pi into, see this is nothing but, see 1 into dx, it is x minus this integral of cos 2x is sin 2x divided by sine 2x divided by 2 is 0 to pi. So what is that I have done here? It is, I am splitting into two integrals. 0 to pi, 1 into dx. Integral of dx is x. Minus cos 2x integral is sine 2x divided by 2. If you apply the limits, what will happen here? So this is equal to 1 by 2 pi into pi minus sine 2 pi divided by 2 minus 0 minus sine 0 divided by 2. But you must know that this cos 2 pi is 0. I told you cos 2 pi is equal to 0. Cos sine n pi. See, sine n pi is equal to 0. So this is 0. This is 0. This is 0. So you are left with only this pi. So this is equal to 1 by 2 pi into 2 pi, that is equal to half. So that is B1 is equal to half. So what is that we have got here? B1 is equal to half. So we have got all the results now. That substitute all these values in 1, you get the answer. Now let me write what is that. Therefore, I write here. Therefore, the Fourier series of a given f of x. See, this Bn has values all 0 except for n is equal to 1. But when n is equal to 1, B1 is equal to half. Therefore, it is half sine x. Therefore, this I will write it as, see, it is half sine x. So you see that this is a small thing that has happened. So you see that what is the Fourier series? We have got the Fourier coefficients like this. Now the Fourier series is, it is a0 by 2 plus an cos nx plus bn sin nx. But an cos nx, as I have got, I am substituting the values here. And coming to b, this bn is equal to 0 for all values of n except for m1. So b1 is equal to half. So half into, if we put n is equal to 1, it is sin x. So you see that this f of x, when you take sin x is equal to 0, x is equal to 0, it is, I will write it here, see, this is 0 is equal to, it is 1 by pi plus half sine 0. So I am taking x is equal to 0, so this is x is equal to 0. So we get 0 is equal to 1 by pi plus half sine 0 minus 2 by pi of sin 0. This implies, see, this implies minus c 2 by pi sigma of 246 up to infinity into 1 by n squared minus 1 is equal to, so you take it to the other side, so this is equal to your half. Take this to the other side, so this is 1 by pi. See, it is 1 by pi. 1 by pi. So what happens now is, so what is that you get now? Therefore, you rewrite this 2 by pi into sigma of 2 for this up to infinity, 1 by, you write it as n plus 1 into n minus 1 is equal to 1 by pi. So this is what we get. Now you do the cross multiplication, this pi and pi will go off, this comes. So this implies sigma of 246 dot 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 up to infinity 1 by n plus 1 into n minus 1 is equal to half. So what is that you get now here? Put n is equal to, start giving the values. If we give n is equal to, so this implies, give n is equal to 2, 2 minus 1 is 1, 3. So it is 1 into 3 plus, give 4, 4 minus 1 is 3,